So in this question, there is a block of mass m 2 kilogram is moving with a velocity of v naught towards an massless string k is 10. The coefficient of friction between the block and the ground is mu. Okay, find the maximum value of v naught so that after pressing the spring the blocks do not return back but stops there immediately. This block is going to hit this, okay, and after hitting, what is going to happen? This is going to compress this up to some level. Let me consider it is compressing up to this level. So the compression happened to a distance of x. Now if it is stopping here, it is not at all moving, means it should be in equilibrium. If it is not at all moving, means your spring will try to push it in this direction, correct? Your spring will try to push it in this direction, but if it is trying to move in this direction, your frictional force will act in this direction. If it is not at all returning back, then your spring force should be equal to the frictional force, which is what? Mu into n. So spring force is nothing but kx. So kh should be equal to mu into n. So here your n is going to be mg, there is no doubt in that. What will be the value of x? It is nothing but mu mg by x. So by using this, we can find the value of x. Okay, but the question is what is the value of your maximum value v naught? For that we have to use the conservation of energy. When it is hitting, the velocity is v naught. The entire kinetic energy will be converted into your spring potential energy, and then what? When it is coming and then hitting here we have friction. Am I right? So if you have friction, so when we are sliding here, the energy is spent to overcome the friction. So the work done by the friction. So this is nothing but work done by the friction. Here is the tricky part. So the potential energy stored in the spring plus work done by the friction, I can split into two. Work done by the friction up to 1 meter, and then after a distance of x. So work done by the friction by 1 meter plus work done by the friction for a distance of x. So we can find what is this x. Oh, I made a mistake. This is k. So mu is given as what? Mu is given as mu is missing. Without mu, how we can solve? Here we have mu. Without mu we cannot solve. Here we have answer in meter per second. It's a new number. I think mu value is missing, we cannot solve, but this is the idea to solve this question. Okay.